Modular. Hello everyone. Let me just introduce myself. My name is João Setil and I am a composer and also a modular system enthusiast. I would like to share with you a concept that I have been working and thinking for a while. And the core idea is to think about modular systems not exclusively in a linear way, and perhaps try to architect a circuit that is circumscribed to a sort of feedback that is the result of some module or some process can be fed back into the system and affect the process in some way. This is going to be a compilation of videos where I'm going to use this concept in different situations. Perhaps it might be a bit advanced for some of you, but I will try to make everything clear so the beginners can also follow. Okay? So I already have here Ableton Live session. I have a glockenspiel and I have a scale quantizer. It's not really important, it's just to have some music background that is actually pleasant while I'm explaining the process. So the environment I use to work my modular system ideas is Reaktor. Although I also have my physical one, is still under construction. Okay, it just have a few models because this is a very expensive hobby. So what I can, of course, you are free to use Eurorack and also Max or whatever program you think you can do these modular connections. Because at the end, the models I'm going to use, they actually exist in physical way and also in other programs that work with modular concept. So what I consider a linear way of thinking and also a linear path in the connections is, for example, this. So what I have here is a clock that is actually synchronized with my Ableton Live, and it's running at 8 notes, and every 8 notes it sends a gate to the sequencer, and the sequencer move one step forward, and the sequencer, these are just voltages that go from 0 to 10 voltage, and somehow then I use this model here that is a MIDI out that is also connected with the Ableton Live and sending pitch MIDI information to the glockenspiel. It just converts this 0 to 10 voltage to 0 to 127. That is the range that the MIDI works. So I can expand this idea in a more complex way. So perhaps I'm gonna use clock divider. Let me see if I can find one. So here we go. So the clock divider is self-explanatory. It needs a gate. So I'm gonna connect the gate from my clock, and what it does is for instance, every 6/8 nodes is going to send a gate through the channel 1, and every 5/8 nodes is going to send a gate also. These as 6 channels, but I'm only going to work with 2. And by the way, this works in parallel. Okay, we will see further what I'm talking about. So maybe I could, since I'm gonna use only 2 channels, maybe I will need a switch. Okay, and what the switch does, I connect in one channel and I connect another channel in the second channel of the gate, of the switch, sorry. And what it does is every time it receives a gate on this input, is gonna switch to the other. So its only output, it just split the channel in 2 paths. So every time it receives a gate, it alternates in between both paths. Never the same, never both at the same time. I'm gonna have to put it here instantly, otherwise it's just do a smooth passage, and I don't want this. It's not really important to know why. So after I finish my this process of 6, I want to switch to the process of 5. Okay, so I could every time a gate is sent from this output, I could connect directly to hit a gate just to switch my channel, right? But I cannot do this because in Reaktor it's not possible, because the CPU will start get nuts. It's like driving nuts, because it start like generating infinite numbers, and it doesn't really matter what it happens behind it. It doesn't allow it, but we can always use something to solve the problem. So I'm gonna use a trigger delay. Doesn't really matter the amount of delay that I'm gonna put it here, because the only thing it's gonna do is every time it receives a gate, the gate only is sent from the output on after a certain amount of milliseconds. Okay, so I could connect now this on the gate. Okay, now I have to do something else, because imagine, for instance, if I have one process going on 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1. And I have another one working on 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1. So when I finish the process of 6, I don't want to catch the process of 5 in the middle. I want it to reset it and start from the beginning. So for that purpose, I need to connect my gate also here on the reset. Okay? And if now from my switch, I can reset my sequencer, and now it's gonna run. So what it's doing is alternating in between 6 steps, 5 steps, as you can see. See? Now it's alternating in between 2 and 5 steps. So this is actually a very interesting process, but there is nothing wrong. Let me tell you just in advance, there is nothing wrong about this. What I want to explain now is that although I have a process running here that is affecting my sequencer, if I change the pitch, the only thing that is going to change on the sequencer and the whole process, like if we see the whole process as a whole, it is still behaving in the same way. It's always alternating between 3 and between 5, right? So we could think that we could actually say that there is not actually a true integration in between both processes. Okay? So this is what I'm referring about thinking in a non-linear way. Okay? Because at some point, even if I have a process that is here supporting my sequencer to behave in a different way, the direction of the whole communication is unidirectional, right? It's just because now I have another thing working in parallel, but they are all working on the same direction. There is nothing that is being fed back into the system that somehow change it. So that's what I want to try to explain it here. So this process, if I change something here, it's not going to change anything in the whole process itself, only the pitches. So now I'm going to just connect the switch here. Okay. I'm going to just put these here just aside for a moment. And I will need, first of all, what I want to do is I want to use a certain clock division. I want to use one of the voltages at that certain time to use as a reference to reset my sequencer. Okay? And for this I will need a sample and hold. If you don't know what is a sample and hold, I can explain you. So sample and hold is just, you have, I'm gonna connect here on the scope for you to see what it happens. So you have to connect the LFO on the input of the sample and hold. Let me put the scope here so you can see. So now you have a scope here, and we have our sine wave LFO. And now at this point the sample and hold is not sending anything because it needs to receive a gate here. So I'm gonna use here through the reset, I'm gonna send, because every 1/8 nodes also now is sending a gate. So if I connect, you see what it happens here, right? So every time it receives a gate, it just frees the voltage at that point. Okay? So I could use this, for instance, to track the voltage from the sequencer. Okay? And I also will need a comparator. I'm also going to explain what is a comparator. I just delete my LFO when I shouldn't. So, in some way, you have to connect in the input of the comparator, my LFO, and you can look at the scope. Okay. So, the way the comparator works is I have to connect also the comparator on a scope. So the way the comparator works is, now it's working on negative and positive directions from -10 to +10. So I only want this to work in unidirectional, so only give me positive voltages. So the way the comparator works is I have a threshold and now is at 0. And this means that every time the LFO crosses the 0, the gate goes to 10 volts, and when it crosses again, it goes to 0, goes back to 0. Okay? But as soon as I start increasing my threshold, as you can see here, now imagine that my threshold, the line is here, is not in 0 anymore. Okay? So this is how the threshold, the comparator, works. And as you can see, this LFO goes from +5 to -5 volts. So here say 34.7, but this is actually, if I have 50 is equal to 5 volts here. So I have 50. As soon as I go higher than the range of the LFO, it doesn't send any clock, it doesn't send any gate anymore, right? So I have to put it, see? I have to put it a little bit in between the range, right? So this is what the comparator do. And this is very useful. Now, I also need to tune my comparator, because the comparator has 2 channels where I can modulate the threshold or whatever value where this kind of device appears next to. And this works as an attenuator, right? But the way this is scaled is not really reflecting what I want from the sequencer, and you will see why. Because, as I told before, the sequencer goes from 0 to 10 volts, as you can see. See, the highest pitch is here, 10 volts, the lowest one is on 0. Okay, so I have to tune my comparator, and I will show you why. And sometimes we have to do this in our own modular system, because the range of the input of some model, it only accepts certain ranges, so we have to try to make everything compatible somehow. So let's see what I what I want to show you. So where is, I'm gonna use a macro knob. It's just a knob that sends constantly fixed values, okay? And as you can see here on the scope, now is on 0, and then see, is the red 0, 10, 0, 10. It goes from 0 to 10. This is me messing up with the knob, as you can see. Okay, so now my threshold also goes from 0 to 10. Okay, but what is happening here is that if I connect this in my modulation channel A and I put on the maximum, what is happen is that as soon as I reach the 5 volts, the 50, that is equal to 5, is already on maximum, okay? And if I want to track this pitch information that goes from 0 to 10, this is not gonna reflect it well, okay? So I have to use, I have to scale this modulation. So I will need to use a attenuator, okay? The attenuator somehow is gonna compress the values, okay? And in this case, I want to compress the values to a half, because if as soon as I reach the 50, it's already on maximum, I have to compress these values to a half. So I'm gonna also goes, if it's an 100%, it doesn't affect the values of the macro knob. So I have to put it here on 50, and then if I connect on the modulate channel, now you can see that it goes from 0 to 10, okay? So now my comparator is tuned and is ready to go, so I don't need my macro knob anymore. So now what I need is to actually, I need to track my so the sample hold is gonna freeze the voltage of the sequencer at certain clock division. So I can use this clock division here to actually froze those, okay? See? So it's frozen my sequencer at certain clock division. See? So depend of the values that you use here, it will change the behavior, okay? I can put it like here every 7, every 4, 5. See, it's freezing every clock division, is freezing a certain pitch here. So what I can do with this is, now I can use this to modulate, and don't forget that you have to pass through the attenuator. I can modulate the threshold of the comparator. See? So is using the reference of the sequencer to the comparator. So every time the voltage here on the sequencer goes higher than the reference that is here, the gate is go on the positive, and then when is below that reference, the gate close. So it's sending is actually generating gates. So I actually need to connect also these in my comparator for the comparator to be able to know what voltages are running. So now I can use these to reset my sequencer. And now, as you can see, this is what I mean about true integration. Because now my sequencer is not working in a linear way anymore, and is actually presenting a very fixed pattern. But as soon as I change the values here, it changed the pattern. And if I also change the values here in my clock divider, is also gonna change here back. See? So somehow everything is connecting now. So it's like if I have a live organism that every time I interact with it, he just give me back a different answer, right? It's not like if I change the pitch and he's just like always inert and doesn't say anything rather than what I command him to do, right? So this is what I was talking about of integration, okay? Although this process is still working independently, is supporting the process of the feedback that is working here, okay? And the beautiful thing is that the way you sequence your voltages affect the pattern that you are doing here, right? See, now we have a different pattern. I'm gonna put a little bit fast. And I actually advise you to actually try out with values that are actually higher than the sequencer itself. So then, and try to work with perhaps like numbers that are not subdivided by itself, by one of another. Okay? So there is always a different pattern. Okay. Good. So now I hope you understand what I was talking about, okay? So now I want to just try another thing. I want to use transposition also. I want to work with transposition. But instead of having like for instance, a sample and hold that is just throwing random voltages and then is summing my voltages with the voltages of the sequencer to do the transposition. I could also use at certain clock division one of these voltages and offset a percentages, yes, of the voltage. For that reason, I would need an attenuator that also has like a kind of offset in order to sum with the values that I have in my sequencer. Okay, so I'm gonna use here this. Okay, so what I want to do is I'm gonna use another sample and hold. Okay, I'm gonna track the voltages from the sample and hold, and the voltage, every time it frees one of the voltage I want to modulate here. So I have to pass the values through the attenuator. Okay, and I want to modulate my offset here. Okay, so if I put on maximum, it's gonna sum, if this is 10, it's gonna sum another 10. So I don't want this because then it's just go higher than 10 volts. So I just gonna do a little bit. Okay, so now since I have here a clock division, I gonna use the third channel to actually gate. Okay, and now I'm gonna connect this in the output, and now it gets everything very low. So I need to put this on maximum. Okay, because this, as I told you before, it works like a kind of a compressor. It's like shrinking the voltage. If I put very like this, it just go between, it just moves slightly between voltage. So I have to put on maximum, and maximum means that it's not gonna affect it's not going to affect the voltage from the sequencer. So what I want is to modulate this. So it's already my sample hold is working already. As you can see, the gate here is flashing. So if I use just a bit, so every 8 notes is transposing, is just picking up one of the voltage and use this as a reference to transpose just a small bit. Okay, so this is what I want to show you. So as you can see, the transposition is actually coming from the information of the sequencer. Okay, so again, there is integration here. And if I put different values here, it's gonna change the way it transposed. See, every time I change something on the sequencer, it just behave in a different way. It's like if it's alive. And if you think back, if you think well, this is actually how the world works. You live in a certain environment, and everything you do affects the environment. and the environment, if the environment change, it also change something on you. So then here it's form a feedback loop, okay? Everything as a consequence, and that consequence as another consequence. So I hope that you understand what I was talking about. I find this very interesting because modular system is actually a language, a paradigm where you can actually work these you can set these kind of connections in a very easy. You just have to grab a cable and connect to some input to output and connect it back. And for instance, in Ableton Live, this is not possible, right? You could use the Macs, and you could use several Macs devices in different channels and try to route them, but it would consume a lot of CPU and will be a mess. As you can see, I'm with this process. It's not really very complex, but it's only consuming like 15% and on Ableton, and also is on like 4.5. Okay, so you are free to comment and actually share your own thoughts. They will be very welcome. And actually I would like this channel to be an environment where you can actually interact and share your own ideas, okay? So thank you so much for watching, and I will see you on the next video. So be tuned and subscribe to have your notifications. So bye bye, thank you so much, and see you soon.